Three-Eye Atlas is not alone. A flock of comets have arrived into our inner solar system. What does this season of cometary activity mean for us here on Earth? What is Three-Eye Atlas revealing about itself as it continues to release carbon monoxide, carbon dioxide, nickel, and now copious amounts of water? What have we learned and what can we potentially learn from this interstellar interloper? Is there any connections between the arrival of Three-Eye Atlas and these other comets as we see in the media? Well, let's talk about that. Join me for this episode as we discuss comets, Three-Eye Atlas, and near-Earth objects here on Squaring the Circle. Well, here we are for another episode of Squaring the Circle, and we're going to continue our conversation talking about these cosmic visitors to our planetary environment, interplanetary environment, and see if we can discern any important lessons to be learned as far as our presence here on Earth. And to engage in this very interesting conversation, I'm going to be joined by my friend and colleague and fellow researcher, John Arthur. Welcome, John.
Howdy, sir.
Howdy. Here we are again. Didn't we just do this earlier today, or that was last week, wasn't it?
It was last week.
My, how time flies.
Yep. Lots of data.
Lots of data. And you've been
Lots of
doing some
studies.
great research. I've been engaged in, we're moving ahead, John, on, it looks like, a purchase of land, which we're going to have some news and updates about that in the near future. So I've been got involved with that, having to come up with some basic infrastructure numbers because there's not much infrastructure on the land at this point. So we have to figure out some costs for the initial development phase.
New school.
Yeah, that's the idea of school. And you better believe one of my criteria for this was that there was some high areas and there is a ridge on the property. And of course, I'm envisioning an observatory up on that ridge so that when we get these celestial visitors, we can just take a little hike up to the ridge and we'll have an observatory and we can view them real time as they're coming in, and I think that would be a really great asset to have. Anyway, so we've both been doing some research, but you've really done made some interesting findings about a number of things, new information, which is constantly being updated as we learn more about Atlas. Three-Eye Atlas. I think the consensus now, and I'm pretty much accepting that it's a comet. Is that where you're at with it?
It's a very, very interesting astronomical body.
It's an anomalous, whatever it is, it's anomalous. And we may be learning, that so far we mostly see comets. In fact, I think 100% of the comets we've seen are from our own solar system.
Yep.
They formed out of the same nebula, the same condensation of gases, and so on. With these interlopers like Oumuamua and Borisov and now Three-Eye Atlas, we're seeing objects that had their genesis in other star systems. So they could be different in a lot of ways, anomalous when compared to our own objects from our own celestial neighborhood.
Indeed.
And that's kind of what we're seeing, isn't it?
It is, and there's a lot of clickbait out there. There's a lot of folks out there saying, "Oh no, there's seven comets coming in, all with Three-Eye Atlas," and it's going. Most of those are local neighborhood asteroids. There's one or two that might be, there's a question if they're an interstellar, but they're all from different angles. All likely from our local solar system gaggle of asteroids. sorry, in
And
comets.
and not part of an entourage that's accompanying Atlas.
It's
Three
not
Eye
so.
Atlas.
It's not quite so apocalyptic, but it's a very interesting cometary season. So,
No
and
kidding.
I think we should
And
talk about it.
yes, because yeah, and this is one of the things that's always interested me is that at least when I really started studying comets, which was post 1980. I had a book on them as a kid. I was fascinated, but then I kind of forgot about them. But I was always very, very interested in the in dinosaurs as a kid and growing up, and the big mystery of what happened to the dinosaurs. And then, of course, in 1980, you had three papers published independently that all proposed a celestial mechanism for the extinction of the dinosaurs at the end of the Mesozoic. And of course, the most famous one was the one by the Alvarez team, Walter and his son Louis Alvarez. No, Louis was the father, Walter was the son. And that reignited my interest in comets and asteroids and so forth. And then one of the things I learned early on as I started reading about it was the idea that the delivery of comets to the solar system, and I'm going to say the inner solar system, will define that as essentially the region within the planets. And then the outer solar system, I think we could think of that as the disk and the cloud, the Kuiper disk and the Oort cloud. The zone of the planets kind of naturally divides into two. The inner silicate-based planets, which are Mercury, Venus, Mars, Earth and Mars, those four. Then you get into the big four outer gaseous planets, which is Jupiter, Saturn, Uranus, and Neptune, right? So that's sort of the natural division of the planetary zone of the solar system. And then outside that is the cometary zone. So we're talking about comets that are being delivered from our own neighborhood, which is the disk or the cloud. Typically, the disk comets are coming in at a low angle of inclination to the ecliptic. The Oort cloud comets can come in from almost any direction, highly tilted, or there's nothing that would exclude them from being also in the plane of the ecliptic, which might then confuse them with the comets that originated from the Kuiper disk. But one distinction between the two is the period. The Kuiper disk comets tend to be much shorter period, and as we're going to look, some of the comets you've got there ready to show us are much longer, like Swan. I think we
R2
saw
Swan.
R2 Swan. We're going to look at that, and it, I think, had a period of over 22,000 years. And you're going to show the graphic of that. But the thing that fascinated me was the idea that the delivery of comets to the solar system or the inner solar system is not a uniform process, but is actually clumpy. That there are periods where there are a lot of comets showing up all at once, and then it thins out for a while. I think of it almost as, if you're, sort of a kinematic model of which, for example, is reflected in like traffic patterns. And of course, that's going to be influenced primarily by your stoplights and so on. But even without that, there still tends to be a clustering. Like you'll notice that you'll be sitting there waiting to make a turn. There's a lot of cars coming, and then it thins out. You take your turn, and then if you sat there for a while, you'd see there'd be another clump of more congested. That's the word for that kind of phenomenon is kinematic. And so cometary delivery to the inner solar system, I think, is also can be described as kinematic. And we're kind of seeing that right now. We're kind of seeing, as you're going to show us here momentarily, it's pretty impressive. Now, some of the work of other astronomers that I've read going back to the 80s, like Victor Klube and Bill Napier and William Asher, Duncan Steele, there's a group of them that have been working on this literally since the 80s and looking at this phenomena of like even I think one of the terms that's been coined as a comet epoch. And then the implication of that is that you have multiple comets over a short period of time, and these comets are breaking up and fragmenting, then you have the potential for a heightened possibility of encounters with the debris. We're going to see, with respect to Comet Swan, we're going to see that potential is there, although I don't think it's going to be anything catastrophic necessarily. Well, John, here I am. I'm on the homepage of Ground News, my new favorite tool, and we were talking a lot about comets, and I was reading from a very interesting article about Comet Swan, and I accessed that article in its entirety through Ground News. So I'm going to go here to my For You category, where it's giving me articles and recent news on things that I'm interested in a lot. So we can go through, we can see some of the Camp Mystic flood, because I put in that I'm very interested in any breaking news about floods and the effects of disasters, natural disasters. That's one of the categories. Another one that I'm really going to dive into, maybe this would be good fodder for our next episode. Blind spot near Venus hides city-killing asteroids. NASA's Artemis II ushers in new era of human exploration. So you can, if you subscribe to Ground News, you can set up your own categories. You get a bunch of categories. You can pick the categories that you want Ground News to alert you to, articles and breaking news and so on, relative to these categories that you have chosen. So that's what I've done. So you go here it gives you the headline, and down here you can go right there to the whole story. What you've got here: Associated Press News, independent media, very high factuality, and it leans to the left. So this is telling you right there, if you're an independent like myself, I'm always looking at outside, the constrictions of the tribal approach. I want to know, what is the left saying? What is the right saying? What are the independents saying? Ground News very conveniently breaks that down for you, so you can immediately assess the bias of a source of information. And I use it now because I like to look, okay, what is the left saying about this? What is the right saying about it? Usually center of the two, when it falls right in the center, that would be for somebody like myself who would be an independent. For my listeners, you can get a month subscription for $5. I mean, what's $5? $5 is 2 or 3 days of the daily newspaper. And 40% off. So you get 40% off the regular price. And if you are interested, and I would highly, highly recommend, and here's why. As we go through these stories, I will quite frequently be giving references and links to these stories that we're accessing through Ground News. So if you're a subscriber, you're going to be able to follow a lot of what we're doing and talking about, particularly topical information that's coming along. So if this is something that interests you, not only is it a great tool to use for anybody who does any kind of research, but it's also going to help us here. It's going to help us by bringing in a little ad revenue that is going to allow us to upgrade constantly our delivery of really interesting and important and valuable information to you. So you can go to the link below. You can go to a link. Am I pointing in the right way, John?
Close enough.
Close enough. And where I think we've got 3 places where folks can link if they're interested in subscribing, right? We've got the link below. We got and there's one more, right? It's hidden somewhere.
It's a QR code. Yeah, there's
the QR code. The QR code. So, yeah, please do it. Go ahead, pull the trigger on it. Get subscribed to Ground News. I think you'll be glad you did. And that way, when John and I are discussing very interesting or important topics, we will be referring to, just like today, I was looking at a paper that we accessed through Ground News. So I'm very impressed with the power of the tool. All right, let's get back to the show. You had some updates on the nickel water circumstance with with 3i Atlas, right? What's the
Correct.
latest on that?
So the latest that I have right now is this paper from Rohan Raja Gaunkar. That's hard to say. So I apologize for butchering that name. But VLT observations of interstellar comet 3i Atlas from quiescence glow, dramatic rise of nickel emissions, and incipient cyanogen outgassing at large heliocentric distances. So this is as of August 27, which is interesting because it gives us a little bit of a timeline that, and we'll get to the timeline in just a little bit, but the outgassing of nickel is important because it's unusual to have pure nickel. It's usually nickel and iron. So
Right. And here you're getting pure nickel.
And here you're getting pure nickel.
Is a siderophile, which means it really likes iron and typically wants to bond with iron. But here we've got pure nickel. So why is there no iron?
So the current understanding is, so some folks are saying that nickel is part of a space engine and it's being outgassed. That's a theory. Okay, that is a theory that has been proposed. And look, hey, let's put it out there. Let's talk about it. But nickel carbonyl has been suggested, which is a nickel atom surrounded by a 4-set pair of carbon monoxide, and so that is an organic metal organic compound that could very well explain the release, because nickel carbonyl, my numbers that I have here are 74 to 82 degree Kelvin is where these would sublimate. And so once they sublimate and it breaks apart, carbon monoxide, which I have here on my notes, is a 25 to 35 degree Kelvin sublimate temperature. The carbon monoxide would just fall away and would strip and leave the nickel all by its lonesome.
What was that temperature in Kelvin again?
So for nickel carbonyl,
yeah,
the estimate that I have here is 74 to 82 degrees Kelvin.
Well, let's just say 80 degrees Kelvin. Okay, so that is minus 315 degrees Fahrenheit.
Cold.
It's very cold.
Very cold. The Kelvin scale. Yes.
If you found yourself underdressed at 315 degrees Fahrenheit minus, you probably wouldn't last past your first breath.
Correct. So carbon monoxide is going to be one of the first things that outgasses. If you assume that this is natural, you're going to have carbon monoxide is going to be the first thing that wants to outgas and sublimate at about 25 to 30 degrees Kelvin, which, by the way, 0 Kelvin is absolute Kelvin. Right. The fifth proposed state of matter, at least when I was studying this way back when, was Bose-Einstein condensate. That's frozen to the point where you're starting to lose definition of what the molecules are. The electron orbits are so low, it's just goo. It's below frozen. It's electronically frozen. So 25 to 30 Kelvin is very cold, but that's where you start to have carbon monoxide off-gassing. 80 to 90 Kelvin, somewhere in there, is where you have CO2 start to sublimate, if it's dry ice.
Yeah, so carbon monoxide sublimates at about 25 to 30 degrees Kelvin. Okay, right. So I'll mention then that's minus 400, roughly minus 400 degrees Fahrenheit. 25 Kelvin's 414 degrees Fahrenheit. And then you said carbon dioxide, like dry ice, that's like 90
80
Kelvin.
to 90 Kelvin.
Okay, so minus 300 degrees.
So somewhere in between there, nickel carbonyls would start to off-gas, which is where we kind of see the cyanogen would be right around, well, if it was bonded with the hydrogen, so you have HCN, That would be right around 79 degrees Kelvin. So that tracks with what we've seen as far as this object has gotten closer, the temperature goes up, and these different releases may not be a mechanical mechanism from an alien contraption. Could be, but there is a natural explanation for it as well. There is a natural explanation. And H2O would be at 150 to 170 degrees Kelvin is where it would start to sublimate.
Okay.
You would get those you would get the ice crystals coming off.
And yet still I mentioned 150 degrees below 0 Fahrenheit.
Very, very cold.
So it's still very, very cold.
It's still frozen.
It's still frozen. I would like to mention that one of our original sponsors at Cosmographia, CBD from the Gods, is following us here to our new podcast, Squaring the Circle. As many of you know, I've been using their products for going on 4 years now, and having tried a number of CBD brands, CBD from the Gods seems the most effective for my needs, which is primarily as a sleep aid and as a remedy for inflammation and associated pain. I use both the oil and the salve. My wife also likes their products, especially the salve, which alleviates the pain in her hands, which is the result of working for years as an electrician. If you've been thinking about trying a CBD product and experiencing the benefits for yourself, give CBD from the Gods a try. To learn more and see their product line, check out cbdfromthegods.com. Any purchase of their products helps our efforts here at Squaring the Circle to realize our goal of making this world a better place. Thanks. But it is, like you said. So there was something, I had a question there as you were talking. Back up for a second. Let's just mention that, go back to the first page, that the VLT means Very Large Telescope.
I love that name.
Yeah, me too. VLT. Observations of interstellar comet 3I Atlas II. From quiescence to glow, dramatic rise in nickel emissions and incipient CN. That's your
Cyanogen.
Cyanogen, right there, outgassing at large heliocentric distances. So, again, heliocentric, we're talking about the distance from the sun. So, out there where this thing is traveling, obviously, the environment is very, very cold. Yet, as it gets closer to the sun, it's warming up, and then these natural processes that we've been talking about here begin to kick in. And these various molecules that we're talking about here, the cyanogen and the carbon dioxide and the carbon monoxide, they all begin to sublimate at different temperatures. So what happens is it's coming in on its heliocentric journey, it's beginning to warm up, and this is what I consider the second phase of the life cycle of a comet, where essentially it's waking up from dormancy. Now, wherever it came from, and we still don't know that yet, it's somewhere, we assume, from within the Milky Way galaxy. I think we've settled that it's not coming from another galaxy, it's coming from another star system within the Milky Way. But wherever it came from, it's probably been on a very long journey, and most of that journey, it's in deep space, and the temperature is down close to 0 in the Kelvin scale. So it's frozen, it's been hibernating, and now as it's approaching, it's coming into the zone of influence, the sun's zone of influence. We see it starting to wake up. Problem is, it's going to come through so quick and be out of here so quick that our window of opportunity to study it is pretty much gone by February, March?
By about March is our last opportunity.
Yeah, and then it's headed back out to who knows where.
Correct. So once that tail activates in a normal comet, you'll see something like this.
Yeah, that's a good little graph there, yeah.
So the dust and the gas tail will sometimes be different, right? But it's always being pushed away by the solar influence, by the weight of the solar wind.
Yeah.
Except we have an unusual eccentricity with this.
Right.
So that's where this image is really helpful. And your little legend on the bottom is important. To the sun. If you're listening on audio, maybe you've heard of this as well, but we'll describe it. You're seeing not a lot of tail, but this bucking of the headwind towards the sun. And there's actually a glow towards the sun. There's almost some people have called it an anti or a reverse tail. So this is where a lot of people have said, well, maybe this is an alien, and its thrust reversers are on. Maybe
it's trying to slow down while it comes in. Well, in the spirit of the outrageous hypothesis, it's fun and possibly worthy to consider. Sure. But in the spirit of Occam's razor,
yeah,
I think we should go with the natural explanation first. So that to me would be that, whatever it's outgassing. Like if you can see the image here, look at the where it says down here in the lower right to the sun. You can see if you were to draw along the long axis of this, I don't want to call it a tail really. This cloud is actually pointing towards the sun, and the axis of it is pretty much almost parallel to the pointer down in the lower right corner. Now, okay, would we look at that as a coincidence, or is it because that side facing the sun is now receiving more energy and is now beginning to outgas, to devolatilize? And so it's in the direction that, I guess that's where I would speculate. And I'm not an astrophysicist, but if you've got one handy, we might call him and ask him. But
well, I think we should call up Dave Jewett, because David Jewett's been one of the most prolific authors on this. I'd love to get his intake.
Right.
And so we'll take a little piece here. This is Hubble Telescope Observations of Interstellar Interloper 3I Atlas, David Jewett et al. So here in this abstract, he says, we present a high angular resolution observations of the third known interstellar interloper 3I Atlas from the Hubble Space Telescope. The object is clearly active at 3.8 astronomical units before perihelion, showing dust emitted from the hot sun-facing side of the nucleus and a weak... Right?
Yeah. Mentioned 3.8 AU is astronomical units, and the astronomical unit, I think a lot of the listeners already know, but for those that don't, it's the distance from the sun to the earth. So this is 3.8 times farther away from the sun than is the earth.
And this is normally where you see a lot of comets become more active, but this sucker was active at 6.
Now that is unusual.
It was mildly active at 6, and the high amount of CO2 is largely believed to be the reason for that. Anyone who says they know might be stepping out in front of their skis. But it's highly suspect that the CO2 is really the primary reason this thing was so active. And they're suggesting we add a simple model to estimate the mass loss rate in dust. And what this means is they believe that the summary of this is 12 to 120 kilograms per second of dust being released. If there's dust built into that matrix, Randall, and you have this dry ice matrix that is sublimating and releasing, what's that going to create?
Carbon dioxide?
Well, you're going to have a carbon dioxide cloud, but if there's dust built into the matrix, you're also going to have a large coma.
You're going to have a large coma. And there's going to be presumably a lot of nickel in that dust.
There's going to be a lot of nickel in that dust, especially if you have a nickel carbonyl matrix, in there, that's going to start to break apart because CO breaks apart or sublimates earlier than nickel carbonyl. But that nickel is the bond that keeps it all together. But once that bond is broken, that CO is now in the wind. So you're going to have a large tail start to develop. And this is where Jewett comes out and says, okay, the 1.5 time increase of expected increase in brightness of 3i Atlas was superseded, or it blew past the expectation to 5 times the increase of brightness from one point to the next in its travel into the solar system. Part of that reason is it's probably dumping mass a lot faster than a local comet, because local comets don't have that 8-to-1 CO2 to H2O ratio that we see in 3i Atlas. So add the early sublimation, add some dust between 12 and 120 kilograms per second being offloaded. And you had calculated how much dust that is per hour. It's a lot of dust. Do you still have that number handy?
Yeah, let's see. Well, a kilogram's 1,000 grams. A kilogram, and then 2,000 kilograms is a metric ton, correct? Yes. Okay, so we're looking at, if we take the higher of the number here, 120 kilograms per second, then that would be 120 times 3,600 would give us 432,000 kilograms per hour. Divide that by 2,000 to get metric tons. That's better than 200 tons per hour, right? So that's a bunch of stuff being dumped into space.
It's going to be much more reflective. So that, I'm not saying that this is the case closed, but to say that it's impossible for this to be natural. There is a good, solid Occam's razor. This is a natural comet that we've never seen before. It's a new type of comet, something that we've never really laid eyes on. And if it's 2.8 kilometers in radius, it has the ability to off gas that much dust.
Yeah, and that is we are talking radius, not diameter here.
Correct.
What did you say? 2 point what radius?
2.8 kilometer radius.
Okay, 2.8 kilometer radius. Okay, so then that would be about 1.7 miles for those who are living in. For all you Americans out there, all you fellow Americans. So yeah, we got, I can see the equation here. You got the difference in mass divided by the difference in time. Gives you the outgassing. And let's see here, your A subscript mu is the mean particle size in microns. So those are some pretty small, not visible to the naked eye.
Yeah.
With 1 less than and equal to the mean particle size, which is less than or equal to 100, we infer that dm over dt approximates 12 to 120 kilograms per second. So then, so in that equation, they're including the mean particle size that's being dispersed. And then there's just, for clarity, I mean, I think anybody who's been listening to us up to this point knows then that the nucleus the comet is composed of the nucleus, which is essentially the dense mass at the core of the thing, and then that's surrounded by the coma. And then the coma is this gaseous, dusty envelope that we see forming around it. And then you have the tail, which is the stream of ions coming off of that. And then you have the trail, which can coincide with the tail, or as in the graphic you just showed, you'll notice that the tail and the trail are distinct. So your gas tail, look at there. Well, they're calling it the gas tail and the dust tail. I think when I learned it, it was the gas tail and the trail to differentiate. in conversation, you talk about the tail, we're talking about the gas. The trail, we're talking about the dust. Now, they can be separate, as you see here, or they can more or less coincide with each other. But again, the important thing is that they are such, the gas and the dust itself, like we just saw here, submicron size dust, that is going to be swept outwards away from the sun by the pressure of the solar wind. And this is why the tail is always pointing away from the sun.
And that lends to the unusualness of this one, is because we do have a tail somewhat of a pressure going towards the sun, which is unusual, but maybe looking at the amount of CO2 that could account for it, or it could be aliens. I mean, I'm not going to rule anything out, but I'm leaning heavily towards strange comet.
Yeah, me too. And it would only make sense. Look, if it's from a complete, we don't really know. I mean, so far the comets that we've become familiar with are all homegrown.
Solar system. They're all local solar system comets. These are from something else. They're from planetary, the protoplanetary disks in the center of the Milky Way or something, or some other solar system, some alien foreign solar system. Don't know how much dust it has accrued going through the cosmos, where it's been, what it's seen, and that could also change. If you take a log of dry ice from Kroger, and you go roll it in the dirt, and you shine a flashlight on it, as that dirt gets released, as that stuff sublimates, your albedo, your reflectivity is going to go up.
Yes, so, and let's mention the effect of albedo that everybody would know is if you put on a white shirt in the hot weather, it's going to radiate more of the heat. It's going to reflect, rather, more of the heat than a dark. Put on a black shirt, it's going to absorb heat. You don't ever find me outside in a Georgia summer wearing a black shirt. Being a Minnesotan, I get very, very warm very quickly. But that's the albedo. In effect, you're saying you take off your black shirt and put on a white shirt, your albedo has changed.
Correct.
And it's the same way I've kind of learned about albedo by studying the ice ages and what happens when you get large portions of the Earth's surface covered by ice. It changes. It can literally change the albedo of the planetary albedo.
So, how do we map this sucker? How do we get a good beat on it? Because we're going to be on the opposite side of the sun when this thing hits perihelion.
Yep.
So, the only options we have outside of the Hubble Space Telescope, the Very Large Telescope, the James Webb, all of those options are things that are already in the air. We're way too late. So in this article that I sent you and you sent me when we were both looking, we both sent each other this article.
We did, didn't we?
3i Atlas, direct spacecraft exploration of a possible relic of planetary formation at cosmic noon.
Now, in this reference to cosmic noon, let's get into that.
Okay.
What did we mean by cosmic noon?
Cosmic noon, earlier formation of the cosmos.
Let's see.
After everything was put out into the galaxy, the galaxies are formed.
An examination of 3i's pre-encounter kinematics shows it is likely to be an object from the galactic thick disk, and thus a remnant of the galaxy's cosmic noon period of intense star formation approximately 9 to 13 giga-years ago. That's longer than you and I have been around together.
By a mile.
If confirmed, 3i will provide a means to explore the stellar and planetesimal formation process and its astrobiological implications in an earlier period of galactic history. But Unfortunately for terrestrial observers, the 3i perihelion will happen when it is on the other side of the sun, as seen from the Earth, at a solar elongation of 12.80 degrees, rendering observation from Earth or near-Earth space telescopes hard or impossible. And with the retrograde orbit inclined 175.114 degrees, that's almost, when you say retrograde, let's stop right there for a second. All of the planets appear to be moving from the west toward the east. And if we were looking at the solar system from above, that would be counterclockwise, right? Now, if we look at the moon from night to night, it's moving from west toward the east. If we watch the apparent motion of the sun, which is really the motion of the Earth around the sun, but the apparent motion of the sun throughout the course of the day and then the weeks and the months, it is moving from the west towards the east along the plane of the ecliptic, right? When we say retrograde, we're talking about something that's moving west to east, back up, east to west,
I was going to say,
not west to east. So retrograde, it's going, and some people listening, I'm sure, are familiar with retrograde motion of planets, which isn't really, to clarify, the planet is not actually stopping and then going backwards in its orbit. In one of our podcasts, we should show the graphics of that because it's quite interesting. It's usually just an illusion that the planet, like in question, let's say Mars retrograde, we see it looks for a period of time as if Mars is moving backwards, meaning moving towards the west, relative to the stars, the backdrop of fixed stars. But it only occurs when the Earth is lapping the object in question, right? And it's much easier to understand if you have a graphic. But basically, retrograde means it's retrograde. It's moving in the opposite direction from everything else. So everything is in the solar system is moving towards the east, and then this thing comes in, and it's moving towards the west, relatively speaking. Also, somebody asked in one of the comments, they were wanting to know when we said that the relative velocity of 3i Atlas, what was that number? Do you recall the number? I mean, it's
at perihelion, the high estimate is 68 kilometers per second.
Per second. That's an impressive speed. Well, when we talk about that velocity, we're talking about its velocity relative to the sun.
Correct.
Somebody asked about, well, relative to what? They want to know. Well, it's the sun.
Correct.
And, of course,
it's on the reference. It's on the reference frame with us traveling at 200. I think it's 220 kilometers per second.
Now, would that be because we're moving in opposite directions?
No, it's on the plane of the ecliptic within 5 degrees of inclination, and that plane is moving 200 and something kilometers per second. So it's also moving along that vector.
I see. So So in other words, the plane of the ecliptic in which it is moving, it's embedded, is essentially moving with the sun through the galaxy.
Correct.
So what you're saying now, that is the sum of those two
vectors,
velocity vectors. And so, well, it's just like anything. If you are out driving down a 2-lane highway and you're driving behind somebody and then you go to pass them, your relative velocity is going to be relatively low compared to you're driving along the highway and a car is meeting you head on and you're both going 60 miles an hour and you pass each other. You're passing relative to each other, you're moving at 120 miles an hour, right?
Correct. So relative velocity, big deal, which is a problem for those who are looking at how can we get a good image of this, because some of these space probes that are out there are going to be, actually almost all of them are going to be seeing this from the perspective of retrograde. So you have a very limited window to view. So Psyche as per Jewett here, or sorry, not Jewett, per this study, Psyche was recommended, but at the time of recording this, we're recording this on the 25th. It should be going out this weekend. September 4th, it's already passed. But October 3rd, High Rise and Hyric on Mars. Lucy and Hera missions, also October 17th and the 21st. They'll have an opportunity to see 3i Atlas. The Europa Clipper mission, JUICE, October 28th, November 4th. Osiris Apex, December 12th. Anything from Earth, our best shot, because it's going to be coming around from the sun, and the best opportunity for us to see it / our perigee with Earth, our closest lineup as it's coming through to Earth. It's going to be December 19th. And then Juno, which we'll go over in a little bit, remind me, Randall, but we're going to look at Jupiter's trajectory. It's going to pass right through the cometary tail of 3i Atlas. So we can get hopefully a good look at what it's leaving behind.
Yeah.
But up until then, the October windows are going to be primarily head-on.
So the difference, again, using the analogy, the difference would be if you're trying to take a photograph of a car when you're passing it, it's going to be plenty of opportunities rather than if you're meeting it head-on.
Correct.
And it's passing you in a split second. You've got just a quick window to snap some photos. Let's talk a little bit. Okay, Psyche, let's go back to that. That sounds interesting. Now, that's the Jet Propulsion Laboratory, NASA's Jet Propulsion Laboratory. It's a payload of instruments, in effect, is what it is, right? It's not a singular spacecraft. It's actually a payload of instruments.
Correct.
And what have we got there? We've got a multispectral imager that can look at multispectral, just what it says. You can it can image it across the light spectrum. It has a magnetometer as part of that payload. So it's going to be looking at, now I don't know if it's going to be able to, it's not going to probably be able to do any, collect any data on the magnetic. If there's any magnetism, I wouldn't think that it has that ability. It also has a gamma ray and a neutron spectrometer. So those are the three instruments that could possibly be deployed to collect data.
Do you want to look at that NASA video on Psyche? I wasn't familiar with the Psyche mission.
I'd love that.
Researching
I think that would be great.
So let's go ahead and pull that up real quick just so that we can see.
All right.
There aren't many classes of objects left in our solar system that we haven't looked at up close with a spacecraft. And one of them that's left is the metal asteroids.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal rich.
It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do. And it would be the first metal object that humankind has ever visited.
After launch, we cruise through interplanetary space for a number of years. First, we fly by Mars for gravity assist that'll slingshot us into the asteroid belt. And then we're thrusting all the way from there to finally arriving at Psyche.
We'll go into 4 orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche, also a gamma ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche, and then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic to when you actually are on the launch pad and you say, we're go for launch.
And you feel like singing and dancing, and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
So we're hoping that they got a good look at that. Mm-hmm. There's been no release that I'm aware of to date on Psyche, but there's Psyche and then there's Lucy. Those are 2 independent payloads, and Lucy is a lot like Psyche. It's looking for one of the proto planetary asteroids. Mm-hmm. And they're looking at that and seeing what they can do with that mission as well, much like Psyche. So some people have asked, why can't we just retask Psyche to deal with 3i Atlas? Well, 1, your time, your orbit, and your time. B, it's already kind of doing something cool.
Yeah. Well, think about this. Okay, so Psyche is an asteroid, so this mission gets its name from the asteroid. So basically what this is a collection of scientific instruments, like we just saw in the video, that is pretty much dedicated to the study of this particular metal-rich asteroid. Now, I should mention, there have been some estimates on the value of the metal in dollars in Psyche. Would you believe 100,000 quadrillion dollars? That's the estimate for the value of Psyche as a metallic object. I'm going to say
what you're
that
saying is
100,000 quadrillion dollars.
Asteroid mining? Is that what you're proposing, Randall?
Well, I've long been an advocate of believing that we don't have an option. We have to build a spacefaring civilization, and we're a species confined to the surface of this planet, which, even though its resources are vast, almost beyond comprehension, they're still finite. And we see that policy is being driven by this Malthusian conception of finite resources. And the whole geopolitical spectrum is essentially built around the control of planetary resources. Well, if we become a spacefaring civilization and we start mining, and I'll use the word harvesting, the infinite resources of the cosmos, we have essentially pulled the rug out from under the need to compete, sometimes militarily and through war, for a finite terrestrial resources. If we're mining asteroids, we don't need to be mining the Earth. It's that simple. I mean, if you're an environmentalist, that should be a big positive. Could we mine? Is that science fiction? No, it's not. It's no more. Relatively speaking, when you consider the footprint of humanity in space already now, compared to in my lifetime, When I was born, we had no presence in space. I was six years old when Sputnik first went up in 1957. And that was our first little foray, humankind's first little foray into the realm outside the Earth, into an extra planetary or cosmic realm. Look where we're at now. I mean, the fact that we have a presence in space, and this means our technology, is how you and I are sitting here having this discussion. We are now, what, 1,000 miles apart?
Something like that.
Something like that.
Used to be the control room had to be in a studio where you and I could see each other through a panel of glass. I'm able to produce from Texas while you're in Georgia.
Yeah, and now people all over the world can tune in and listen to what we're doing. Watch us real time. Now that's okay. If you were to describe this situation in the 1950s, this would have been science fiction, and a big part of humanity would have been, oh, get out of here. That's all science fiction. That's great for the science fiction and the Hollywood movies to, imagine that you've got things in your hand, that you can talk to each other over distances and everything, but it's all science fiction. Well, we're in an analogous position now. It is not science fiction to say we could be harvesting asteroids. And the irony there, the interesting thing about that is, and we are going to talk more about asteroids too. We need to do that. And I think you and I had already agreed we would put together an episode or two anyway discussing asteroids, which in their own way are a very interesting cosmic creature to learn about. But the thing is if we're harvesting asteroids, a lot of the technology that we would employ is technology that is already now being developed for the purpose of fighting wars. So when you're talking about Lockheed and Raytheon and General Dynamics and Boeing, et cetera, then the billions of dollars they're reaping in profits. Well, I believe they could actually be making more in profits if we retool, if we essentially forge our swords into plowshares. And so all of that's within our reach. In fact, I think we're closer now to being able to harvest asteroids than we were in the 1950s, to be you and me being able to sit here talking to each other at 1,000 miles away in real time. The other interesting thing is that as we learn more and more about the denizens of near-Earth space, and you've got an incredible graphic we're going to look at here before we're done, our cosmic neighborhood is densely populated with stuff. And most of this is the debris and the remnants of ancient cosmic catastrophes, right? Well, the stuff that we're learning about, we have a class of objects out there now it's called NEOs, which is near-Earth asteroids. Well, none of those are predicted with any certainty to collide with the Earth in the next century, although there's going to be some close encounters coming up within a couple of decades, which we're going to talk about. Not today, but we will talk about that. Here's what the irony I guess I'm getting at is that the more dangerous the object is, literally the more accessible it is. Because obviously it's going to be easier to mount a mission to a near-Earth object than it is one that's, at many astronomical units away, clearly. And so that's the thing is now as we develop this census of who we co-inhabit near-Earth space with, I think we'll come up with a list of objects that could let's say within the next millennia, have a fairly high probability of being encounters with the Earth. And given what we now know, and another subject we've got to talk about is the growing evidence for far more impacts and encounters than anybody was imagining a generation ago. And even some of these, even though they wouldn't be extinction level events, they could be civilization killing events, or if not civilization killing events, at least dramatically powerfully profound effects on civilization. I mean, we could be talking about collapse of the digital grid worldwide. We could be talking about the collapse of supply chains around the world, even from a small impact event. And this is in my opinion, a category of natural disaster that is being overlooked and neglected, not by scientists mostly, but by policymakers that should be looking at this big picture and going, how do we plan for a civilization that's still going to be around a century from now? And we've gotten kind of diverted off into thinking that the big threat to us is carbon dioxide. And that's another thing that we should address in some depth, because there's a lot of misinformation. And when I've noticed, and we'll get back to our discussion here about these comets, but several times I have been accused of spreading misinformation about the question of climate change. Yet,
up, there it is. The Wikipedia article is underneath the video on YouTube, not on Rumble, but on YouTube. It's there now.
Where?
On YouTube, there's now a climate change denier label on YouTube. Now that you just said that,
of me, that I'm denying climate change.
Since you just brought it up, yep, it's there.
Well,
I'm telling you, it's going to be there.
This is the utterly bizarre, because what I've been saying literally for 30 years is our climate of this planet is extraordinarily dynamic.
Yep.
It changes. I mean, all you have to do is consider the extreme difference between the late glacial maximum and now, and how rapidly the late glacial maximum gave way to the early Holocene warmth. I mean, like that. This is climate change on a scale that nobody's yet able to explain. Now, I'm sitting here talking about how incredibly dynamic the climate is, while somebody is accusing me of being a climate change denier, which is, to me, is just utterly absurd. It's so absurd, I don't even know if there's words to express it. So it's like being accused of spreading misinformation when the ones, whoever these anonymous, and it's somebody anonymous out there who is hiding behind their anonymity, they are the ones spreading misinformation. Because clearly it is misinformation to accuse me of being a climate change denier when I was talking about extreme climate change for a decade before global warming even became an issue. Anyways, I didn't mean to get off on that rant, but
so less Green New Deal focus and more Lucy and Psyche probes for terraforming, for mining, and also more DART-like missions where we can actually have something that's capable of intercepting a 3i Atlas and understanding what it is.
Yes.
And getting a better understanding of where to go.
Because there will be more interstellar interlopers. I think this is clear from what we've seen now.
At this point, it's more than a statistical probability. It's probable that we've been missing a bunch.
Oh, yeah.
So, on that note, do you want to get into SWAN and what you found via our sponsor that we talked about earlier, Ground News?
Yes, absolutely. Before we do that, you mentioned a DART mission. I just want to clarify what that is. DART, D-A-R-T, stands for Double Asteroid Redirection Test. Because it wasn't Bennu. What was the asteroid that we rendezvoused with? We actually rendezvoused with a small asteroid with a moonlet. And we showed that it's within our technological reach to be able to redirect asteroids. So that would become very useful twofold. One, redirect an asteroid that could be on a direct collision with the Earth, or redirect an asteroid to where it becomes more accessible for us to be able to, essentially extract its...
That was the moonlet Dimorphos,
Dimorphos, yes.
the moonlet of Didymos.
Didymos, yes. So dimorphos, two forms.
Dimorphos.
So Didymos was the primary, and then there was a moonlet.
Yep.
And we attempted to divert or to redirect.
Just a
the
little push.
Little push, a little nudge. Because if you catch the thing early enough, a little nudge can have a very large effect over a period of time.
Correct.
Okay, with that said, let's move on to talking about Comet Swan. I think that's going to be, because this is, look at this. Look at this. Oh my gosh, that is beautiful.
R2 Swan promises to be the belle of the ball for late 2025.
All right. Discovered on the 11th of September of this year. So just recent. That's, what is that, a week and a half ago? Something. Astronomer Vladimir Bezugli. And from the SWAN instrument. Now the SWAN, this is where it gets its name. That is the solar wind anisotropies. Solar wind. So it was actually a sun observing instrument that was aboard the SOHO. Solar, that's where you get the SO, Heliospheric Observatory. SOHO. Okay, so that's it. So this was an instrument aboard SOHO by which they discovered Comet R2 Swan. And this is where the name comes from. Swan is the solar wind anisotropies instrument aboard the SOHO spacecraft. It is also the 20th comet discovered via SWAN's ultraviolet sky images. Let's see. So on the 12th of September, it reached perihelion at 0.5 astronomical units. So about half the distance between Earth and the Sun. Right. If we go 93 million in round numbers is the distance from Earth to Sun. So if we divide that by 2, it gives us 46. Let's see, 1, 2, 3, 46 million. 500,000, 46 million miles, basically, which is about 75 million kilometers. And it has this extremely eccentric orbit, very elongated. And I believe you've got a graph there for us to look at.
I do.
Look,
so we're going to talk about Lemon a little bit.
Okay.
But Swan, R2 Swan. This red is R2 Swan. Very eccentric. And it is a long period comet.
It goes way out. I mean, it's out there beyond the orbit of Neptune even.
Yep.
Wow. Okay. And so its period, it will not return again for what? We saw about 22,000 years.
So there was some conjecture that it might be interstellar, but it looks, based on what we see now, it looks like it is a long period Kuiper or Oort cloud comet. So for those who are chalking it up as to it being related to 3I Atlas, unlikely. You'll see a lot of clickbait about all of this coordinated motion from 3I Atlas. No primary sources cited.
Of course, you never see that.
That's why we try to make sure that we put these in the description so you guys can go research them yourself. We try to also read them so that you can go look it up yourself. Nothing up the sleeve here. It's all open to you.
Right. I think I mean, this proliferation of clickbait, I'm thinking maybe we need to deploy like the equivalent of SWAT teams to go track down the origins of this bullshit. Look, there's a place for speculation, and again, the value of the outrageous hypothesis, but be clear, I'm conjecturing. This is conjectural here. So you got two camps. You got one that has almost like no id at all, no controls. It's whatever. Then on the other side, you got this hyper conservative that you're not allowed to speculate. We find that in too many realms of science where you have gatekeepers that think they've got it all figured out. They don't. And anybody who asks the wrong questions gets pushed out to the margins. So we're trying to find that balance between open-mindedness and the willingness to speculate, the willingness to ask outrageous questions, but at the same time, ultimately being conservative, trying to, trace our sources, know where it comes from, whether it is credible or not, whether there's independent verification and so forth. Peer review is important. However, peer review has been subject to abuse. Let's be clear on that.
Well, Galileo was peer-reviewed wrong, wasn't he?
I think that he's a good example of that. Yeah. Now, let's see. What do we got here?
So we've also got A6 Lemon. We've got G3 Atlas. We'll talk about that. But I want to look at Lemon. So there has been some there have been statements that Lemon is going to be a problem for us. It's this comet right here. It's going to create meteor showers, or we're going to have issues with the debris. But as you can see, when we come around here,
boom, it just passed Earth's orbit.
Long before. We're not going to have too much of an issue there.
We can back it up again. So we're at the outer red there. That's Mars orbit. Back it up to where it's right juxtaposed on Earth's orbit.
Yep. And let's play it.
Okay, which one? I've lost.
So this is Lemon.
Oh, there's Lemon. Okay.
Lemon. So not a whole lot of contact.
It's coming around there. It looks like it's making perihelion right in there somewhere.
Yep.
Coming around. Ooh, look at how close it's coming to Venus.
Mm-hmm.
Then it's crossed the Earth's orbit. Now it's crossing the Martian orbit.
And we're way over here.
We're way over there, yeah.
So some of the different, again, some of the YouTube videos, chasing down studies, just looking for different things people are saying about 3i Atlas. I've run into so many of these stories that I look for a primary source, and there just isn't one.
Right.
So,
which right there is cause for suspicion about
always.
The veracity of the story.
So just so that everyone remembers, the Atlas Monkier is for the observatory that is finding them. This is the one that we really missed out talking about, because in January is where it really was kind of a beautiful comet, G3 Atlas. So this has been a great year for comets.
Let's be clear that G3 Atlas is not interstellar.
And it's not related in any other way other than the observatory. The crew that saw this first was the Atlas crew.
Yes, that's right.
So, important to note.
Yes.
So for those of you who are concerned about the gaggle of asteroids that are coming in, or comets that are coming in regards to 3i Atlas, which is out here, by the way.
Yeah.
Very, very different, unrelated orbit. Okay. Not particularly related. And again, Atlas is Asteroid Terrestrial Impact Last Alert System. That's what Atlas stands for.
Mm-hmm. Could you say that once again?
The Asteroid Terrestrial Impact Last Alert System. Atlas.
Okay.
So just so that you guys can see. Now let's have a little bit of fun. Let's look at a couple of near-Earth objects.
Now, a near-Earth object is going to presumably be asteroids. Now, we're not including comets within that category, are we? We're strictly talking asteroids.
Just asteroids that are near us. You can see here in September, we're going to have a near pass. Here, let's actually pause this. In September, we had this near pass right here on the 13th with NEO, let's see here. What is that? 2025 SY1. So just watch these two.
Yeah, I see the Earth is the blue sphere.
Earth is the blue. Look at how close that is. Now, for everyone who's worried about the comets, let's put one better. So that's not all the near Earth objects. Let's have...
Wait a minute. You're saying that there's more than this?
There's a few more.
There's a few more?
Looks more like this.
Mm-hmm. Now, that is interesting. And yeah, can we let's see, where is Earth hidden in? Look at this. That's crazy.
That's Earth in all of this. So when we talk about a galactic pinball machine, my cursor is on Earth. For those of you who can't tell, we're talking dozens upon dozens upon dozens mapped near Earth objects and really tight intersections often. Not uncommon to have stuff come through within 0.2 astronomical units. Very, very common.
Mm-hmm. Mm-hmm. So, seeing that, one might suppose that could be a serious matter. It could be a matter of concern.
Worth thinking about.
Worth thinking about, right?
Someone did a paper on 2024 YR4, and they upgraded the chance of it impacting the moon by 1% from 3% to 4% recently. That's not significant per se, but if you had a lunar impact from 2024 YR4, which is a near-Earth object, nearly hit us in 24, came in between us and the moon. If that fella decided it wanted to whack the moon real hard, the shower of breccia from the moon would not wouldn't intrude into the atmosphere, but it might knock out the ISS and all of your satellites that you hold so dear for your day-to-day infrastructure, your GPS, your television, your spy network, your defensive satellites.
Right.
It would be an issue of concern. So once again, here's the Earth, just so you can see all the time.
And we are going to continue to have close encounters regularly. I mean, we're with the current census, we're looking at something like a relatively close encounter, like once a month, compared to what we used to track when we weren't even noticing. And I think that would be, again, something else we need to talk about is because I've been collecting and cataloging these near misses since 1988 is when I started. And there have been dozens and dozens and dozens of them since then. And if we go back to, let's see, what was the first asteroid? 1801, Ceres, Ceres. One asteroid in 1801 that we knew about, right? And that was the first telescopic discovery. And its diameter, 583 miles. Now, that's in no danger of hitting the Earth, but that's a big object, obviously. If something that size struck the Earth, that would be a planet killer. It would probably sterilize the planet. The second one, the following year, was Pallas. And it's the third largest asteroid in the solar system with a diameter of 318 miles. The next one was Juno, discovered in 1804, and it is the second largest in the solar system at 157 miles. And then Vesta was discovered in 1807. So you see here, early 1800s was the flurry of, so by 1807 we knew about 4 of them. That was Vesta, with a mean diameter of 326 miles. So the first 10 asteroids to be discovered were Ceres, Pallas, Juno, Vesta, Astrea, Hebe, Iris, Flora, Metis, and Hygeia. So that was pretty much by the end of the 1800s. And now it's been accelerating to the point where we see what's going on here. What is the number here? Do you know the number? There's the list of objects.
There's a list of objects.
Obviously in the hundreds. So let's see.
So something around 100, 150, somewhere in there. Okay. Just on this one graph.
So we go from 1801, first discovery of an asteroid. 1898, the first discovery of a new class of asteroids called Eros, which is seen to be approaching the Earth. Then in 1932, another class of asteroids, the Apollo asteroids, which are asteroids that cross the orbit of the Earth, right? That's your Apollo. That was 1932, right? By 1970, there were about 30 near-Earth objects, or NEOs, that were known in 1970. You weren't around then. I was. I just got out of high school. When I got out of high school, there was about 30 NEOs known. 1990, you're getting close. Were you around then?
94.
94.
Not quite.
Not quite. You were on the way in, but you hadn't arrived yet. You were still crossing interstellar space.
Yes.
You hadn't gotten to our solar system yet.
I wasn't 6 astronomical units out yet.
Yeah, you were. Okay. So 1990, there were about 135 NEOs known. 135. And by 1999, by the end of the century, there were about 400 of them. And now I think it's double or triple that.
This is only a small sampling.
Yeah, this is only a sample. This would not even include, I don't think, a Tunguska-sized object. Maybe it would. I don't know what their criteria is. But, think of it. So 1801, first asteroid discovered. 1898, this was the first time an asteroid was seen actually on an orbit that was bringing it towards the Earth. Because prior to that, the asteroids, the first 4 that were discovered, were all in orbits outside of Mars, right? They weren't approaching Earth. Eros was the first to approach the Earth. And then 32, first Apollo asteroid, which was, again, what's its definition? It crosses the Earth's orbit. So that's just a little bit of background. By 1970, there were 30 near-Earth objects had been identified. By 1990, about 135, and now there's hundreds and hundreds of them. So how many more will we discover? I bet we'll continue discovering them. Simultaneous with that, of course, is the knowledge, the growing knowledge of the numbers of times that Earth has been impacted, which again is a much bigger number than anybody was imagining, a few decades or a few generations ago. So this is going to be something that we will be coming back and talking about when we take a deeper dive into asteroids. So leaving the question of near-Earth objects, which, by the way, I think the current estimates are now over 1,500 of them. Some of them could be the debris left over from comet visitations, which we call apparitions. So this approach of Comet Swan, we refer to that as an apparition, which is interesting because that's the same word that we use for the appearance of ghosts and things, apparitions. And that's not just happenstance. I think there is a reason for that. And I get into that quite a bit on my Cosmic Origins of Halloween presentation, which I'm probably going to do an updated version of it at the end of October, if I'm not too crunched as we come up to departure date for the Azores. But Comet Swan will possibly produce a meteor shower. And not, I'm guessing, going to assume, not anything that could be catastrophic to Earth, but a meteor shower like we typically will see with the Taurids or the Leonids or the Geminids or the Draconids or the Aquarids or any of these other meteor showers. All, by the way, are the spawn of comets. So Earth is going to cross the plane of Swan's orbit on right around October 5th. So coming up pretty quick. So there is the possibility when we cross that orbit of there being a meteor shower. The closest, it's perigee, which is closest to Earth, right? Para, like perihelion, means it's closest to the sun. Its perigee means closest to the Earth. Its perigee is going to be on the 19th to the 20th of October. And it will be at 0.26 astronomical units. So about 1/4 the distance to the sun. So that's safe, no danger to us. But in cosmic terms, it's relatively close. And skywatchers are hoping that this is going to be at least invisible to the naked eye. It will certainly be visible to anybody with binoculars. So I plan to be out with some binoculars the evening of the 19th to 20th of October to see what kind of view I can get of this thing. It'd be great to see a really cosmic light show. I've been waiting my whole life. I've seen some good ones, but not in the scale of some of the ones we're going to talk about, the great meteor showers of history, the Draconids and the Leonids, and possibly in the ancient world, the Taurid stream. So we are not saying that, let's clarify that, we're not saying, because some people out there are claiming unambiguously that Swan is another interstellar visitor. We're not saying that. What it's now looking to me like, and I think to you as well, John, is that we're looking at a very long period comet on an extremely eccentric orbit that carries it way outside the planetary zone of the solar system. What's interesting, though, to me is when you think about even way out there, it can slow down and literally reverse and start falling back towards the sun. Do we know the perihelion velocity of Swan? So let's see. It was found in July, and at first it was considered a possible another interstellar comet.
So
now I think the data suggests that it is not. It's probably just a long period comet that's part of our own solar system.
it's expected to be coming through at about 55 kilometers per second at perihelion.
55 kilometers per second. Okay. So that would be about, just a relatively modest velocity of 118,000 miles per hour.
Pretty fast.
That's pretty fast, yeah. I think we already mentioned it was discovered by SOHO, the Solar Heliospheric Observatory. but it was discovered relatively late in its approach. Why? Because it's coming from the direction of the sun, and it's coming essentially from appearing against the backdrop of stars of the constellation Aquarius, which was in the area occupied by the sun at that time. It remained hidden until just before discovery, because for over a month, which was from early August to early September, it stayed within 30 degrees of the sun's glare. So this causes this observational bias, which we discover more things farther away from the sun than we do close to the sun. In fact, it goes on to say here, was spotted only one day before perihelion, as it finally crept far enough from the sun's vicinity to stand out in Swan's all-sky view. So magnitude 7.4 with an approximate 2-degree tail. And you pulled up that beautiful image, 2 degrees. Here's how the easiest way to gauge that is think about the full moon up in the sky, which we know from total solar eclipses displaces about the same angular distance as the solar orb, right? Which is very close in round numbers to a half a degree. So if you had two lunar disks side by side, just touching at a point of tangency, that would subtend, to use the geometric term, 1 degree. 1 degree. So if you had 2 degrees, think of 4. It's a little bit more than 2, I think. So between 4 and 5 full moon disks lined up tangent to each other, that would be the length of the tail up in the sky. So it brightened quickly, and that undoubtedly had something to do with the fact that it just was passing and had just passed so close to the sun. So do we get to see it here? It appeared in the evening sky near the star Spica, which is part of the constellation of Virgo, which according to some traditions, the Chartres Cathedral was dedicated to the constellation, as were the Notre Dame cathedrals dedicated to the constellation of the Virgin, of course being a reference to Mary. The Virgin, right? And specifically Spica, one of the most prominent stars within the constellation of Virgo, was associated with Chartres Cathedral. So that's kind of interesting. So let's see, what else is there? Let's see. As it says, it's been putting on a modest show as it rounded the sun. It began to unfurl a long tail of dust and gas, which actually precedes the comet on its outbound leg. Everybody watching this now, I think, is going to understand what that's referring to. There's a green tint, which you see right here, very obvious. Often seen in comet tails and comas, and it is most likely from the vaporization of diatomic carbon and cyanide gas. So, yeah, there's a family of these emerald comets that are chemically going to be similar to Swan. So, what else there? There was a post-perihelion outburst, which shouldn't be surprising. Sudden surge in brightness from magnitude 11 to magnitude 7 in early September, and this suggests that volatile ices were exposed, or a chunk of the nucleus may have spalled off during that perihelion close encounter with the sun. Anyhow, it looks like at this point it's probably stabilized as it's moving away from the sun. So, so best viewing time will be early to mid-October, with its peak again around, what did we say, the 9th and the 10th, or the 10th and the 11th?
So it'll be the You said October 5th, roundabouts.
5th will be its perigee.
Perigee.
But, oh, is that? No.
That's going to be
Crosses
the night.
orbit.
It's going to cross the orbit. Perigee is, I believe, the 19th.
19th. Okay, yeah. So let's see. If it maintains at least binocular brightness, which would be with a magnitude 5 to 6, it could be a pleasing sight with a visible tail after dusk. An astrophotographer, Gerald Riemann, has been quoted as saying, quote, "If the comet continues to behave as it does now, we'll have a great comet in October."
It'll be October 21st. Perigee.
Perigee.
Confirmed.
Okay. However, as it goes on to say, experienced comet watchers will point out that comets can be very fickle creatures. And they can sometimes fade out or even disintegrate. Unpredictable. Suddenly and we've seen a lot of comets in our episode on comets. We looked at that phenomena of disaggregating comets nuclei coming apart and producing dozens or maybe even hundreds of sub-nuclei. And that's probably what the Tunguska object was.
And that episode will be coming out after this one. We wanted to be timely with all of the potential satellites and the infrastructure that could view 3i Atlas. We wanted to give a timely episode.
Yes.
So that'll be coming out next week.
And the significance of the October 5th date, let's reiterate that. That is the date that Earth crosses the
Swan's
orbital
path.
And so that could be the day to watch out for meteors.
So we wanted to get this out before then. So
yeah.
We already recorded that one. So if anything's out of date there, our apologies. I don't think it will be. It's all pretty timeless information.
So I've been referring to a great article here that I retrieved through my my new great tool that I use. That I will mention again, Ground News. So this was a TechSpace 2.0. This was linked directly from Ground News. So I wanted to learn more about SWAN. I simply go in the search field, SWAN R2. Boom, I've got half a dozen articles right at my fingertips. And each one leads me directly to the original article. We were complaining about things being posted that you can't get back to this. What's the source of this, right? Well, this is one of the powerful attributes of this particular tool is you can get right back to the source. Anyhow, do you have anything else of interest?
Well, we do, but I think we're going to have to save it for next time.
Well, we might just have to do that. There's always more, isn't there?
There's always more.
And yeah, we've got.
What are you drinking for everyone in the comments section?
Oh, I am drinking. It's 50% pomegranate juice and 50% coconut water. Fairly healthy, I think. It's very refreshing. So that's what I'm drinking. I've pretty much cut high sugar. I mean, there's a lot of sugar in pomegranates, but it's a natural sugar. There's no added sugar in what I'm drinking. I'm trying to stay away from the sugary sodas and things. Occasionally will indulge. I guess the one time where I do sort of like let go of my strict discipline is when I'm doing a lot of driving, when I'm driving, somewhere for many, many hours. And I figure, okay, what would be worse for me to have a mild sugar spike or to get onto, to fall asleep and weave off the road and become a fatality. So I've decided, I'll drink a little something with some caffeine and some sugar in it just to see me through till I get to the end of my journey. And then I won't touch it again for months. So a little bit of insight into my particular idiosyncrasies of life. which we all have, don't we?
Indeed.
Maybe you might be an exception to that, John, because no. Back, you remember Cosmographia, Mike Waslevek? He was sort of like, remember we called him normal guy? Because compared to myself, Brad Young, and the Brothers of the Serpent, we were all kind of more out on the fringes of normality. So it was kind of good to have him as sort of a standard against which our eccentricities could be referenced. Of course, it turns out he's not as normal as we pretended. But anyways, we hope he's doing well. He was being treated for leukemia. And so we really are hoping the best for Mike. I want to mention that. Keep him in your thoughts and prayers. We want him to get well. And I think he will. I mean, he leads a pretty healthy lifestyle. So anyways, what else do we want to, anything else we need to mention other than the fact that we've got a great itinerary of stuff that we want to get into and explore on upcoming episodes of Squaring the Circle. And we're trying to have some kind of coherency to it, so that if you want to learn about comets, if you want to learn about these interstellar interlopers, we're trying to take somewhat of a deep dive. We're trying to be somewhat of an antidote to what has been referred to as TikTok brain, that seems to have an attention span limited to 7 seconds. We're trying to shift it back to kind of what was in the days of our ancestors of not too long ago, where you were expected, one of the ways that this manifests, for example, is sometimes I'll read books from classic works like from, say, the 19th century, and you might have a sentence that takes up an entire paragraph, one sentence. And it's sort of the difference between, what do you call it in a movie, a tracking shot, where you follow the protagonist or whatever through multiple scenes without breaking the camera.
One shot.
Yeah. And then you see these where it's boom, 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 back and forth. One of the actors speaks for 2 or 3 seconds, cuts away, it's a different actor. Might have been recorded on two completely different days. Well, remember, before movies, and in the early days even of movies, people went to plays, where you see the actors up on stage, right? They might watch a play that lasts for 9 minutes or 2 hours. All those actors have to know their parts fully, completely, right? So anyways, we're trying to get at least back and present like I said, an antidote to the TikTok brain. And we'd like to encourage anybody and everybody who's of, we would say, the younger generation, to keep that in mind, because it is part of mental development to be able to follow a train of thought for more than 7 seconds, right? And it's like dumbing down. It's like the difference between our ancestors who went and worked outside every day, got exercise, burned calories all day long, out working in the sun and the fresh air and all of that, compared to just sitting in front of a computer now for hours and hours every day. We will lose the physical capacities of our grandparents and our great-grandparents who could go out in the field and work for hours. Likewise with our mental faculties, right? And if we don't learn how to extend our thought processes beyond 7 seconds, and that's been thrown out as a number, maybe half facetiously, but metaphorically 7 seconds, we're going to see a decline, I think, in our abilities, our mental abilities. Now, of course, then what that leads into is, if your mental abilities, your acumen is declining, the implication is you're going to be more susceptible to being misled, to being controlled. Thought control does not work on people who have active cerebrums who have intellectual capabilities and can think critically. Propaganda is aimed primarily at people who have abrogated or lost the ability to think critically, which I think is a deliberate part of our modern educational system. That's a topic for another episode that I think we should have because it's important. But anyways, that is my concluding statement for this particular episode, that what John and I, everybody, are trying to do is to really take a deep dive into a particular subject. So I think we've done that. I think we've really done. We've been looking at these intergalactic visitors, and we hope people appreciate what we're trying to do here, and you stick with us. Don't lose interest, because who knows what the importance or significance of this is going to be for our long-term understanding and our long-term place of humanity in the universe. I think that this is very timely now that we've gotten 3 back-to-back within 10 years, three of these interstellar objects, and we're undoubtedly going to discover a lot more of them. And we're probably going to then also discover that and realize that these things have been part of our cosmic system all along without us even being aware of it. So it's interesting to consider we might in the future be able to rendezvous with an object that's from a completely different star system. And then we will be able to learn from that. Because right now we are beginning to see sun-like stars that have planets around them. But so far we haven't seen anything that would indicate just that precise arrangement of energy and materials that we've got in our own solar system that somehow makes it possible to sustain higher sentient life, such as you, John, and myself.
And you, Randall. Yep.
And our audience. So I'm going to bid adieu to all you sentient beings out there, and we will see you on the next episode of Squaring the Circle.